Chapter 2.6 is linear inequalities and absolute value inequalities. So starting with the linear inequalities. So these are just like linear equations, except with, instead of an equal sign, it's going to be with an inequality sign. So we either are going to have a less than or equal to, greater than, or greater than or equal to sign. So we're pretty much going to be solving these the same way. Except this time we're going to be finding the set of numbers instead of just one number that makes the inequality true. And these numbers, this set is going to be called the solution set for the inequality. And I'm going to be usually using interval notation to represent this interval for the solution set. So the way that we're going to be solving these is going to be the same exact way that we solved linear equations, except when we multiply or divide by a negative number. So if we multiply or divide both sides of the inequality by a negative number, we have to reverse the direction of the inequality symbol. So that's the only difference for solving these compared to linear equations. So let's do a couple examples here. So we want to solve this and then graph it on the number line. So we have 5x plus 11 less than or equal to 26. So we need to solve for x. So first we have to subtract 11 on both sides. So we're going to get 5x less than or equal to 26 minus 11, so 15. And then we divide both sides by 5. So since it was positive 5, we don't have to reverse the inequality sign. So we get x less than or equal to 15 over 5, which is 3. So that would be our solution set. So it's everything less than 3 and equal to 3. In interval notation, that would be negative infinity to 3 with a bracket on the 3 because it was or equal to. So on the number line here, it's going to be everything less than 3 and equal to it. So we put a closed circle on 3 because we're including it, and then an arrow to the left signifying that it's everything less than it. And next one, we have 3 minus 2x less than or equal to 11. So we wanted to subtract 3 on both sides. We would get negative 2x less than or equal to 11 minus 3, so 8. Then we would divide both sides by negative 2. So right here we are dividing by a negative. So that means we have to reverse the inequality. So it's going to be x, instead of less than or equal to, now it's going to be greater than or equal to. And the 8 divided by negative 2 gives us negative 4. So this in interval notation is going to be everything greater than negative 4, including it. So it's negative 4 to infinity with a bracket on the negative 4. So on the number line, we go over to negative 4 and we put a closed circle because we're including it, and then everything to the right because it was negative 4 to infinity. Okay, well, going back to this one real quick, we could have decided to get the variables on the right-hand side of the inequality instead. If we did that, we would not have to divide by a negative, and we would end up getting the same result. Okay, next one. We have negative 2x minus 4 greater than x plus 5. So let's say we decide to get the variables on the left. So we have to subtract x on both sides. And we get negative 2x minus x is negative 3x minus that 4 greater than 5. And then we would have to get the constants on the right. So we'd have to add 4 to both sides. We'd get negative 3x is greater than 9. And then we have to divide both sides by negative 3. So as soon as we see that we're dividing by a negative, we know we have to reverse the inequality. And we get x is, instead of greater than, it becomes less than. And then 9 divided by negative 3, we get negative 3. So x is less than negative 3. So that means in interval notation, it's negative infinity to negative 3. This time, we don't have a bracket because it's not or equal to. So when we're graphing this on the number line, we can put an open circle at -3 because we're not including it, and it's everything less than -3. Another way to do it is put a parenthesis at -3, and if we are including it, we could put a bracket. I think it looks better with the circles. Okay, I'll do a couple more. We have x plus 3 over 4 greater than or equal to x minus 2 over 3 plus 1 over 4. So this one, if we remember the way that we did this when we were doing linear equations, we would find the LCD and we would multiply everything by that LCD. So the least common denominator here is 12. So the least common multiple of 4 and 3. So what we're going to do is multiply both sides of the inequality by 12. And that's going to end up being, for multiplying the left-hand side by 12, 12 times x plus 3 over 4 greater than or equal to 12 times x minus 2 over 3 plus 12 over 4. So every term got multiplied by 12, and then we're going to use that to cancel all these denominators. So remember, don't distribute that. So 12 over 4 is 3. So it's 3 times x plus 3 greater than or equal to 12 divided by 3 is 4. So we get 4 times x minus 2, and then 12 over 4 is 3. So now we have this same equivalent linear inequality except without fractions. So now we just solve this normally. We have to distribute the 3 on the left. That's 3x plus 9 greater than or equal to distribute the 4 on the right. That's 4x minus 8 plus the 3. And let's work on, well, we can simplify that right-hand side first. We'd get 3x plus 9 greater than or equal to -8 plus 3. We get -5. And let's get all of the variables on the left. So let's subtract this 4x over here. And then in one step, I'm going to subtract 9 to the right-hand side. So 3x minus 4x gives us -1x. And then -5 minus 9 gives us -14. So we have -x greater than or equal to -14. We have to get rid of this negative. We can divide both sides by -1. Or you could have multiplied both sides by -1. So this would give us x. We divided by a negative. So we have to reverse that inequality. So instead of greater than or equal to, it's less than or equal to -14 divided by -1, +14. So we get x less than or equal to 14. Interval notation would be -infinity to 14. 14, we put a bracket because of the or equal to. Okay, so for this one, I'm just going to create my own number line here. So I'm just going to say that 14 is over here somewhere. And then it's going to be including the 14 and then everything to the left of it. Okay, so something like that. Do 2 more. So 2 times x plus 4 greater than 2x plus 3. So once again, we have to distribute here, just like we did in the last one. Distribute that 2 on the left. We get 2x plus 8 greater than 2x plus 3. So let's try to get the variables on the left. We would subtract 2x on both sides. So this would actually cancel the variables on both sides. And what we would end up with is x, or 8, greater than 3. So the variables completely canceled and we got a true statement because 8 is greater than 3. Whenever that happens, that means the solution set is going to be all real numbers, so -infinity to +infinity. So no matter what value for x we plugged in, that statement would always be true. Okay, so on the number line, all you would have to do here is draw a line with arrows on both sides. So that just represents all real numbers. Okay, last one for this one, we have x plus 7 less than or equal to x minus 2. So starting this the same way, we're going to try to get the variables on the left and subtracting x. Once again, it actually cancels both of them, and we're left with 7 less than or equal to -2. So the variables canceled, and this is a false statement. 7 is not less than or equal to -2. So since we got a false statement, that means there are no solutions. So we could say that the solution set is the empty set, and we denote it with that little circle or 0 with that diagonal slash through it. So there's no solution. So no matter what we plugged in, that inequality would never be true. Okay, so now for the second part of this section, we have solving inequalities with an absolute value. So for this page, let's keep in mind that the absolute value, so remember that we use this notation for it, absolute value of x with the vertical bars, it represents the distance of x from 0 on the number line. So let's take a look at this first one, absolute value of x less than 2. So this means that the distance from 0 has to be less than 2. So if we're looking at this in terms of this number line here, less than 2 would be from 0 up until 2, and we would not be including 2 because it said less than. So clearly any of those numbers are less than a distance of 2 away from 0 on the number line, from 0 to 2, but so are these numbers from -2 to 0. So the solution set is not only going to be from 0 to 2, but also from -2 to 0. So the solution set in general here is going to be from -2 to 2. Okay, and then for this next one, let's say this one's greater than x, absolute value of x greater than 2. So that means the distance from 0 has to be greater than 2. So clearly on this side, it's going to be everything greater than 2, not including 2. So that's going to be from 2 to infinity. But we have to keep in mind that it's also going to be everything less than -2. So it's going to be that whole region too. So both of these shaded in regions with the arrows here represent an absolute value of x greater than 2. Okay, so that kind of, those easier examples gives us these steps for solving these two conditions. So first we want to isolate the absolute value expression, and then it's going to get broken down into two cases. If we end up having the absolute value of something less than a number, then we have to set this up so whatever is in those absolute value bars, we drop the absolute value bars and say it's between -k and +k, just like we did on the previous page. And if we have the absolute value of something is greater than a number, that means we have to set it up two separate things and say that f of x, drop the absolute value bars, is less than the -1 and greater than the +1. And after setting up those new inequalities, we have to solve that for the remaining x that's left over. Okay, let's do a couple examples here. We have the absolute value of x less than or equal to 5. So first thing, we try to isolate the absolute value. It's already isolated. Next, we have to look at the inequality sign. Since it is less than or equal to 5, that means we drop the absolute value bars on the x and say that the x is going to be between the positive and negative version of that number. So that's just based off of these rules right above. And now what we would do is try to isolate the x, but it's already solved for in the middle. There's nothing else attached to it. So that means in interval notation, this is going to be -5 to 5. So x is between, it's saying it's greater than -5 and less than +5, which means it's between them. So on the number line here, it's going to be everything between -5 and 5, including those endpoints because it was or equal to. Okay, next one we have the absolute value of x -3 greater than or equal to 7. So first we have to isolate the absolute value by adding 3. So we add 3 to both sides, we get the absolute value of x is greater than or equal to 10. So next we look at the inequality. Since it's greater than, that means we have to split this up, and we say drop the absolute value bars and say that it's less than or equal to the negative or greater than or equal to the positive version. So essentially, this one's obvious, greater than or equal to the positive version, and we just rewrite it and drop the absolute value bars. The other one, we reverse the sign and make it negative. So greater than, it's going to be chopped up into 2 separate intervals. So in interval notation, this is going to be everything less than or equal to negative 10. That's going to be negative infinity to negative 10. And what we're going to do is use a U for, well, the U symbol for a union. And then we're going to say, I have to use a bracket here because we were including it. Union everything greater than or equal to 10. So that's going to be 10 to infinity. Okay, so those are the 2 intervals that we're combining to get our final answer. And then on the number line, it's everything less than negative 10 and everything greater than positive 10. So the absolute value of x minus 4 less than 3. So this time the absolute value is already isolated. So we're going to look at the inequality. It's less than. That means we're going to drop the absolute value and say that it's between the negative version of that number and the positive version of that number. So we say that negative 3, or we say that x minus 4 is between negative 3 and 3. So now we need to isolate x. So we need to get rid of this minus 4. So we're going to add it, except this time we're actually adding it to 3 separate sides. We're going to add it here to cancel it, and then we have to add it to the left and the right. Negative 3 plus 4, we get 1. Less than x, less than 3 plus 4 is 7. So this gives us everything between 1 and 7, and then in interval notation, that would be 1 to 7 with parentheses because there's no or equal to sign. So on the number line, it would look like this. It's everything between 1 and 7 with open circles because we're not including them. Do a couple more here. Next one, we have negative 2 times the absolute value of 3x plus 5 plus 7 is greater than or equal to negative 13. So first we have to isolate the absolute value. So that means we have to subtract 7 on both sides. So we get negative 2 times the absolute value of 3x plus 5 is greater than or equal to negative 13 minus 7 is negative 20. Divide both sides, so it's being multiplied, that negative 2 is being multiplied. So we have to divide both sides by negative 2. And since we divided both sides by a negative, we have to reverse the inequality. So we get the absolute value of 3x plus 5. Instead of greater than or equal to, it becomes less than or equal to negative 20 divided by negative 2. We get positive 10. So once we have this isolated, now we have to look at the inequality. Since it's less than, that means we're going to drop the absolute value bars and say it is between the positive version and the negative version of that number. And since there was or equal to on the original one right here, there's going to be an or equal to on both of these down here. So now we have to solve that for x. We have to isolate the x. So we have to subtract 5 from all 3 sides here. So negative 10 minus 5, that's negative 15, less than or equal to 3x, less than or equal to 5. And now we have to divide this 3 off because it's multiplying it. So we end up getting negative 15 divided by 3 is negative 5, less than or equal to x, less than or equal to, I'm just going to leave that as 5/3. So that is saying that x has to be between negative 5 and 5/3. So in interval notation, this would be negative 5, comma 5/3, and they both get brackets because of the or equal to symbol. And on the number line here, we have it from negative 5 over here. 5/3 is between 1 and 2, so I'll just put it right here. So that would be 5/3, and it's everything between that, including those endpoints. So something like that. Okay, do about 2 more here. So the absolute value of 5 minus 2x minus 2 greater than 5. So we have to isolate the absolute value by adding 2 to both sides. So we get the absolute value of 5 minus 2x is greater than 5 plus 2, so 7. So once we have this isolated, we are going to look at the inequality. Oops. Since it is greater than, we split it up into 2 separate ones, and that's going to be you drop the absolute value and say it's less than the negative version, and you drop the absolute value and say that it's exactly what you see, greater than the positive version. So now we have these 2 separate ones that we're going to solve. So on this first one on the left, we can subtract 5 on both sides and get negative 2x is less than negative 12. We had negative 7 minus 5, negative 12. And divide both sides by negative 2. And since we divided by a negative, we had to reverse that inequality, so we get x instead of less than, it's greater than. Negative 12 divided by negative 2, we get x greater than 6. So the one on the right, we're going to solve that one separately, and we do the same steps, subtract 5. We get negative 2x greater than 2, and then we divide both sides by negative 2. We have to reverse the inequality, so instead of greater than, it becomes less than. 2 divided by negative 2, negative 1. So for this one, it's going to be everything greater than 6 and everything less than 1. So everything less than negative 1, that's going to be from negative infinity to negative 1. And then we're going to join that interval union. It's x greater than 6, so that's 6 to infinity. So we don't have any brackets because it was not or equal to, so that would be our solution set in interval notation. So on a number line, it would look like this. Everything less than negative 1 and everything greater than positive 6. So we'll do one more here, and then I'll just make a note of something. So we have the absolute value of 10 minus x plus 14 less than or equal to 35. So isolating that absolute value, we have to subtract 14 on both sides. And we get the absolute value of 10 minus x is less than or equal to 35 minus 14, 21. And we look at the inequality. It's less than or equal to, so less than means we drop the absolute value bars and we say that it's between the negative version and the positive version. So 10 minus x is between negative 21 and 21. Now we have to isolate the x. So let's subtract 10 to cancel it from this middle. And we get negative 21 minus 10, so negative 31 less than or equal to negative x less than or equal to 11. So now we have to get rid of that negative on the x, so we can divide everything by negative 1. So when we do that, we have to reverse the inequality because it's dividing by a negative. So we get negative 31 divided by negative 1, we get positive 31. We have to reverse all of these inequalities. So instead of less than or equal to signs, we have greater than or equal to signs. 11 divided by negative 1 is negative 11. So you don't want to write it like that. You want to write this in increasing order. So essentially you just kind of flip everything and say negative 11's over here, and now it's less than or equal to, and then the 31's on this side. So all we did was flip the order and re-flip the inequality sign. So it means the same exact thing. We just want these in increasing order. So in interval notation, it's going to be negative 11 to 31. And that would be our interval. And then on the number line, it's everything between negative 11 and 31. And we included those endpoints because of the brackets or the or equal to. So just making a little note, move this over a little bit. If we isolate the absolute value and get the absolute value of something is less than a negative number, that means there are no solutions. By definition, the absolute value is always positive or 0, so it's never going to be less than a negative, so that would be no solutions. And if we get that the absolute value of x is greater than a negative number, that means the solution set is all real numbers, because that will always be true. The absolute value of something is always going to be greater than a negative because it will never be negative. Okay, so those are just two things to look out for. We didn't really get into an example with them, but once you recognize it, you just skip to these answers and then you're done. Okay, so that's it for 2.6.